Okay, so can you hear me? Okay, so let's get started. So welcome everyone to the lightning talks. So are you excited? Great. So this is a brief history of the lightning talks at historical Blinkons. So the number of talks has been increasing. So this year it decreased a bit, but it's simply because we are hitting the limit of the number of talks we can schedule. So this is great. And here is one important rule in this session. I asked all speakers to insert one talking point that will get a storm of applause. So when you find that point, please give a big round of applause. Is that okay? Okay, so let's practice. Not yet. So it's important to improve documentation of the code base, as you know. So I am always encouraging engineers to add documentations to all directories of the Blink code base. And here is the great news. The number of Markdown files increased 50% this year. Okay, so great. So I want to hand it off to the first speaker, so Labjubra.
Which one should I press? This one, okay. So hi, I'm Riju. Today we are going to talk about media capture for the web. Capturing images used to be painful, but we shipped the image capture API in M59. So why today? Okay, sorry. So every time you take a picture on your camera, the camera sweeps across the focal plane and checks for the best autofocus. But what if we want to control the focus ourselves, say like in macro photography? Focus stacking is basically an image manipulation technique where you take multiple photos captured at different focus distances, and the resultant image has much more depth of field. One of the main reasons why users use native camera instead of a PWA equivalent is that it gives pro users much more fine-grained control, like exchanging exposure time. But now we can say, yes, we can. Thank you. So this HDR is basically an image manipulation technique where we take multiple photos at different exposure time. And we use OpenCV.js, which uses WASM to create an HDR picture. So capture, process, and display all in your favorite browser. So for conference-grade cameras, we have also added this pan, tilt, and zoom features. So many Googlers here might know this Meet and the Chrome box. It used private Chrome extensions, but now we can, hopefully that will be deprecated in favor of the standardized APIs. Intel has been making some nice cameras with the depth sensing, and we have enabled this on Chromium. So here's what we can do using that. Here is one example of a simple background removal technique, which can be used on a WebRTC call, just in case you need to take your WebRTC call with your teammates from Hawaii. And another one is AR use case where we have been using our gestures. So all these things are now possible in your favorite browser. Thank you.
Thank you very much. So the next speaker is Michael Ripport.
Micah. I'm working on memory management and garbage collection in V8 and the renderer in general. And I want to introduce you to all-pen concurrent marking, which we are going to build over the next couple of quarters, I guess, which should transform all-pen from this very beautiful but not super efficient thing to something like the German Autobahn of garbage collection. Not yet, not yet. So our motivation is essentially we are roughly 2x faster on the 99th percentile in V8 with marking, and that is even though we have actually a dynamic object model. So with C++, this should actually roughly like a few x faster. Which is why we are going to do this. Very short introduction. We currently have incremental marking in all-pen, which means that we have application running, and we have GC doing marking steps in between. And we want to transform it to something like that with concurrent marking, where some marking helper, thread, or task essentially helps out with going through the object graph. Now, you may wonder what's going on here. This is the point. And so there's lots of concurrency involved, and we thought hard about memory models and so on. And so if you want to take a look and see how this can work out, check out the design doc, give comments, and give us feedback. And yeah, this is what will happen. Thank you.
Thank you very much. So the next speaker is Peter Marshall.
Hello, thank you. Hi, I'm Peter. This is going to be a really short lightning talk. We've been working on CPU profiling in V8. I called it the silent killer, but this is really just a clickbait title. The reason I called it that was because the CPU profiler actually takes a lot of memory. And the reason that happens is because we need to be able to symbolize these frames off thread. So we interrupt the currently running thread, we copy the stack, and then on a background thread, we do the symbolization. But of course, we have a JIT compiler in V8, and we need to know what code is at what address when. This is the symbolization process. And to do this, we store a bunch of information in a side table, and this tells you, okay, this code was here, and then we can symbolize it, right? It turns out that when you enabled this on things like Node.js servers, you would sometimes double the actual heap usage. This is why I call it the silent killer, because people were logging tickets with us saying things like, hey, I turned the CPU profiler on and my server gets killed by the GCP or whatever it's running on, because it uses so much memory. So over the last year, we've actually reduced the memory usage of the CPU profiler by 96%. Which is quite a lot, and now this is something that you can actually reliably use in production. But this is Blink on, not Node.js on, so why am I talking about this? So the interesting thing is that there's a proposal out there right now to add JavaScript profiling as a web API, so you would be able to do this on the client side. And this takes the number of users of a product like this from a handful of developers who are using in DevTools, which is an important use case, but it takes it and it puts it into production where we'll have this actually running on real-world websites while users are using it. So yeah, I'm really excited about that. Thank you.
Thank you very much. So the next speaker is Jose Dapena Paz.
Okay, hello. This is Jose Dapena from Migalia, working on the WebOS project for LG. So we are trying to keep GCC working for Chromium build. I did a talk last year basically telling the same thing, but there are some updates. But the reason for keeping GCC running, it's basically a couple of things. One is that we need platform-specific tool chains. We have incompatibility with system platforms sometimes, system platform libraries sometimes. So yeah, it's important to keep things running and build breaks unexpectedly because, yeah, different interpretation of the C++ standard, difference in how the C++ library works, and bugs, of course. So what we are doing at LG Electronics in this case is maintaining a job to build updated. It's targeting that right now. Hardware targets is Raspberry Pi 3 and Raspberry Pi 3 with both ARM32 and 64 architectures. This is the link where you could get the work. Yeah, we do bug fixing and provide fixes for the GCC build upstream in Chromium. Low, okay. So after several months stalled because of different things, we're back. We are maintaining it again since 2 weeks ago. Okay, so yeah, thanks to all the people contributing to making this still alive and working, because several are still needing it. So yeah, thank you. Yeah, for anything you want to know about this, please ping us or ask for information. Thank you.
Thank you very much. The next speaker is Michael Habrich.
Hi, I'm Michael. I work on V8, and let's talk about JavaScript today. So, according to the Developer Economics report, there are 11 million JavaScript developers out there. And last year, the community did grow by 3 million, so that's a lot. It's the community with the highest amount of developers, so that's awesome. So you might ask, what about business to business? And this is one that's really surprising. So it seems like 57% of developers, enterprise developers, are actually using JavaScript on their job, which is right behind Java. And I think the percentage is like 1% difference, which is also very surprising. But why? Why are people using JavaScript a lot? Because a lot of people are actually saying, oh, JavaScript, ah. So turns out, according to studies, the number one criteria for developers to actually choose a programming language is the availability of libraries. And you might have heard of NPM, that I think here the numbers are like a few years old, served 650,000 of libraries via an NPM registry. That's a lot, so that's one reason. Next one, JavaScript is everywhere. It's in your browser, it's on the servers, it's on the edge networks, it's in those tiny little devices that are fire alarm detectors, for example. Who knows? It's really everywhere. And I mean, another reason might be JavaScript is the only language that's actually supported in all the browsers. But WebAssembly has it there. With WebAssembly, other languages can also run in the browsers, like Rust, for example, C++, and so on. And here's the call to action. Invest in JavaScript coins now, because hockey stick graph is guaranteed. Terms and conditions may apply.
Thank you very much. So the next speaker is Fernando.
Hey, hi. I'm going to talk about a project that I worked on a year ago, I guess. So it was basically text render. If you guys don't know off-screen canvas, is this basically a replacement for HTML canvas element that's not connected to the DOM, so we can actually send to workers and do graphics drawing on workers. The off-screen canvas as the HTML canvas has a 2D context, and what happened there was the 2D context when it was spec. This is actually a screenshot from the spec. It says like that, this line, which not working the button. Yes, there it is. So it says like test render is not supported, which, you know, yeah, and which for me, when the first time I read, I was like, what happened there? Like, why just wrote a line saying this a part of it's not supported? And the reason was kind of because, well, multi-threaded text rendering is not supported on any browser because it was a thing that nobody thought about in the last 15 years. And I thought, like, okay, so can we make this, like, remove that and actually make blink render text in multiple threads at the same time. So then I had a plan. My plan was to just stare at code and try to figure out how to do that. I failed miserably at that because it's not a very easy thing to do, or at least I'm not smart enough to do that. And then after thinking about it and almost giving up, I thought, okay, maybe I'm doing the wrong thing here. I'm using the wrong tool for the job. Like, it's not, I don't have to smart out this. I have to use better tools for the job. And that's when I realized that I had to learn about TSAN. And for people who don't know, TSAN is a thread sanitizer. At that point, I don't know, Gab is here, but Gab was working on adding a bot to support TSAN. And I was like, okay, this is almost working. If I just put myself to it, I'll be able to figure something out. So what I did is I work on like a little library that work on TSAN that allows you to basically write some Blink code and run in a bunch of threads and tell you as a test if it works or not. And then what I went on was basically I wrote tests and kept trying to fix the tests one by one until Blink could actually render text in multiple threads without any of those new tests breaking. And in the end, what I had was, well, now that TSAN is happy, not only I know that I have a thread-safe text rendering, but also it's sort of regression-safe because the test will break. And eventually, with this, I was actually able to go there and update the spec. And now the spec, yeah, that's the part. So yeah, it's nice. So the final thing of this is like, just like I think like it's nice to remember that we need sometimes better tools to be able to do better things. That's not just about trying to ram through it. And that's the talk. Thank you so much.
Thank you very much. So the next speaker is Benoit.
Hi there, my name is Benoit Girard, and I've been working on web performance for almost 10 years. Point left. Okay, cool. So today, I'm really excited to talk about how we do web performance in the industry. So ideally, we want to run performance tests on the web developer's machine, but it's really hard because the hardware is different, and there's a lot of noise due to background execution. So what do? We take the build, we ship it off to a perf server, and that has a bunch of downsides, such as it can be really slow to get results. The results can be very noisy. And then once you get a performance regression, it's really hard to go and debug because you might not have debug symbols or access to the machine. So can we do better than this? Yes. It turns out that probably most of the machines in this auditorium room has something called a retired instruction counter. So all you need to do is you replace the wall time and CPU time with instruction counts. The pro is that this can work, and I've tested this, even if you have hundreds of threads spamming CPU and I/O operations. This is more sensitive than wall time or CPU time. It works locally. You can get results in second. And the main con that I've found so far is that it doesn't catch all regressions as the sleep times, but it's fine. There's other good ways to catch that. And it also requires some more math. So let's go into that math right now. If you want to try to start up in something like 2 seconds, you might say, okay, it's going to take a second and download 1 meg of JavaScript. That leaves you 1 second of execution. How much execution, how many instructions can you retire in 1 second? You kind of run it through this simple equation. A lot of that is very CPU specific. You figure out what are the criteria for your low-end CPU that you want to target. For us, for a high-end machine, we can see something like 2 billion retired instructions that you can fit in 1 second. So now that's your kind of budget for your performance test. So how do we implement this? We just extend Puppeteer and tracing. Andrew Camino's posted a CL for this, where every Chrome tracing block naturally takes the instruction counts. And so that lets us hone on exactly the JavaScript execution that we care about, where product engineers are writing code. We don't need changes to Puppeteer. It's really easy to remove things like garbage collection times that are not really directly attributable to our code, not in an obvious way at least. And the really nice part is we can get an order of magnitude decrease in our performance tests and also be able to run the tests on the developer's machine. This is incredibly powerful. We still do see some sorts of noise. For simple programs, we don't see any noise, but Chrome does branch on things like clocks and things like that. So the good part is that we do have a way to debug this. We can run through something like a record and replay like RR, and we can actually go through and fix all the sources of noise if we wanted to. But right now, we haven't done that yet because the results are actually good enough. So what's next? We're integrating it with the web engineer workflow, and my main call to action is we'd like to see more projects using this, such as web and even native. Thank you.
Thank you very much. So the next speaker is Sadru.
Hi, so I'll be talking about Fuse, which is sort of the non-Blink part of Chrome, but still hopefully it's interesting. So the part that is not red, that's the part that is Fuse. On the browser side, we don't have much of that. On Chrome OS, we have some more, if it works. So on the Chrome OS, the system UI is all Fuse. So that's on the left, it's the overview mode. On the right, it's the app list. We start with an old screenshot because this is what I had. I didn't want to recreate it. So you have the angled tab strip and so on. So this is the browser window on a Chrome OS shell. And it has the Aura windows, if it shows there. So you have some Aura windows for the system wallpaper. We have an Aura window for the browser window. We have an Aura window for the blink part. And then we have the views widget. So for the browser, we have the red thing is the widget, and there's a bunch of view elements inside. I'm not highlighting all of the views or widgets here. And you can also sort of look at this tree in DevTools. If you start Chrome with enable UI DevTools, you can go to that URL and you can sort of see the browser UI. You see on the screenshot, it just looks like a regular DevTools for the web page. So in summary, we have a views widget, which is the top level container. I'll go back. Oops. I'll go forward. And I'll go back, sorry. So you have a views widget, and the widget is the one that sort of manages the compositor, the CC compositor that we have in Chrome. There's a tree of views inside. So you have a tree of views, and there's a corresponding tree of layers. This would be familiar to people because this is how Blink works, or the web works too. So you have a tree of DOM elements or layout trees, and then there's a corresponding tree of layers in the compositor. This is kind of how the interaction happens. So Blink talks to the compositor, and views talks to the compositor. So on the render side for Blink, the focus of the compositor from the start has been for Blink. It used to live inside of WebKit when it first started. There has been a lot of optimization that has happened in CC that hasn't been translated to views. And so the thought experiment here is, what if we put CC or Blink inside of views? So views doesn't have to work on CC directly. And so that allows views to take advantage of the optimization work that is happening inside of Blink for worklets and so on. So that's it.
Thank you very much. So the next speaker is Julie.
Hi, I'm Julie from Igalia. I'm here to introduce AGL and Chromium at runtime from AGL. AGL is automotive-grade Linux. It's a open software platform hosted at Linux Foundation. It's focused on rapid innovation of vehicle software. AGL has more than 130 members now. Yesterday, AGL announced that Volkswagen joined AGL community. Collaborating with LG, Igalia has worked on Chromium and web runtime in AGL. LG opened their web runtime solution, Web Application Manager, WAM, and Igalia migrated to AGL platform. As you might know, Igalia has put efforts for Wayland port during several years. Since last year, Wayland port has worked without additional changes. And LG supported interface layer for WAM, and Igalia added IVI protocol for Chromium in AGL. We successfully launched web application running on the WAM. First two screenshots are web application, and the last one is standalone Chromium browser from the AGL platform. Current status as Web Application Manager works with Chromium 68, working with upstream Wayland port. AGL has Web Application Manager and Chromium at Meta HTML5 framework. AGL is growing fast. AGL showed a bunch of demos at CES this year, and Igalia also showed demo, Chromium and web applications. And AGL also hosts various events, and Igalia also attends actively their events. Plan for the next, we will focus on the stabilization and enhanced performance. And Dape is supposed to give a talk about web technologies in robotics and automotive tomorrow, so check the detail at this session. Thank you.
Thank you very much. So the next speaker is Andrew.
Okay, hello everyone. We're going to stand over here just so that the thing will actually work. Cool. So I'm talking about APK size. That's our binary size on Android. So I'll start with just a breakdown. It's 75% native code, or code that's in the .so file, 10% Java, 10% ICU data, and everything else is really small. Okay, so good things about what we've done for APK size. We have a try bot right now that measures it, and it will go red if you try to add too much code in one commit, and you can always click into it to see exactly how many bytes your code is adding. I'd love it if you'd all check every one of your commits. You can also click through to see where the size is coming from, so it has this HTML browser, and you can also go to this website and find any of our milestones, recent milestones, and just have a look at the binary size breakdown. And then if you're really getting advanced, there's a command line query kind of interface. Here's an example of it for our generated code. You can see Blink, number 1. However, Mojo has been growing at an extreme rate and will soon surpass Blink bindings. My talk was not supposed to have any applause. So, good that we're monitoring. As you may have guessed, there is some doom and gloom here. Mainly for low-end Android phones where Chrome is trying to fit on the system image, we have this target that we're trying to hit and stay under, which is 64.6 megabytes. You can see where the graph goes down. That's when our team has actually made improvements to our binary size, and then when it goes up, that's when we stopped making improvements to binary size. And so that's pretty representative, I think, of the organic growth. 600 kilobytes per milestone if we just stop making it smaller. The last dip there is when we shipped Android app bundles, which was a pretty big effort to take mostly locale strings out. But then the growth is like clockwork, 600 kilobytes each time. So doing some math, we have 100 days until we hit that limit if we don't do anything. So this is the, I don't know, what do you do to do doom and gloom and not clap? I don't know, yeah. Okay, so yeah, that's the end. There's some info if you want to check the slides later.
Okay, thank you very much. So the next speaker is Taku.
Hi everyone, I'm Taku Ikuta, come from Goma team, and my talk is Goma is not silver bullet. In this talk, I introduce some build performance improvement around Chromium development, but all improvement is not come from just using Goma. First improvement is for slowness around very large source files. Because Goma does not improve the compilation speed itself, using Goma may not so effective for large source files. For example, V8 has some very large source files, and compiling those files takes long time. That harms Goma's parallelism. For this, I split some large source files into smaller pieces, and that made build time of V8 shell 1.4 times faster by using Goma. So having rather than large source files, having smaller pieces utilize Goma well. Second improvement is removal of unnecessary build dependency. This is build trace taken from Chrome build around a year ago. And this build trace shows that we have many build tasks waiting V8 snapshot generation. But many compile tasks don't need to wait V8 tasks. So for this, I changed V8 and GN to generate better build graph, and we don't have this serialized dependency now. Next improvement is linker switch. Last year of May, we switched our linker used for Windows from to LLD from MSVC linker. LLD significantly improved build performance on Windows. And by this linker switch, average compile step time on Windows CQ Builder became nearly half. Last improvement is overhead optimization for Ninja. 1.5 years ago, I updated Ninja binary used for Chromium development, and that's improved build performance. That's also improved build performance. Because Ninja needs to span many build processes, we cannot ignore the per build task overhead. And before the update, Ninja took 3.7 milliseconds to create a process, and total overhead became 133 seconds. But after the update, create process overhead become summary. Even if we use Goma, or because we use Goma, we have many spaces where we can improve build performance. And we keep our effort to improve build performance so that Chromium developers get more productivity. Thank you.
Thank you very much. So the next speaker is Yoichi.
Hi, my name is Yoichi Osato. I'm here from Tokyo to talk about Rim Web components with updates today. So, what is? Okay, I see. So, what is Web Component Wizard? They are Chrome-only APIs, and no other browsers implements no longer, and they should be removed. And actually, they are the Shadow DOM Wizard, custom element Wizard, and HTML imports. So, we did. So, first, we sent intent to duplicate and remove, and started showing duplication message, and wait 3 quarters and removed. Not yet. So then usually was broken entirely. Yeah. And there was some news to it, and the patch was reverted in a day. So actually the usage is very, very high. So we can remove so far. So and deprecation message has nothing you can get the web stars even there. So we need some more efforts. So here's plans to work. So we should do more migration effort like table work or reverse origin trials and some peer polymers. And so far we postponed the removal until less usage and defining what is less actually, because the usage includes a polymer or some reverse origin trial, and we can remove even if the usage is high, so or partial removing APIs one by one. So then so many contributors on this project. Thanks for all of them, all yours. Yeah, cheers again. Yeah. Again, we are bearing them. Yeah.
Thank you very much. So the next speaker is Kenichi.
Hi, this is Kenichi from Blink Worker team. Today I want to talk about my hobby project. Implementing server-related stuff sometimes involve, implementing server-related stuff sometimes involve IPC-related IPC. So I have to modify module file sometimes. But unfortunately, we don't have inter-editor support right now compared to other languages like C++ and JavaScript. This makes sense because this is a Chromium or Blink specific language, and people don't have to touch module files so often. But that says, it's nothing wrong to have better editing support. And I thought it might be a fun project to do that, so I decided to do that. The traditional way to add editor support is to write plugin for each editor, but this doesn't scale, as this is my hobby project. So I've chosen to adapt to the language server protocol, which is a protocol to generalize how editor and backend communicate, so a single server can be reused in multiple editors. And today, many popular editors already have decent clients. So what I have had to do is to write the server side. And the server is at an early stage of development, so it just supports syntax checks and code definition. To be honest, code definition isn't useful for module file, but it was really easy to implement, so I just did it. And here's a quick demo. As you can see, editor checks syntax as I type in. And yeah. And this is another demo. This is running on the VS Code. The previous demo was running on the Emacs. And this demo shows how go-to definition works. And yeah, and it's also working, it also checks syntax. Yeah, that's it. Thanks.
Thank you very much. Okay, so the next speaker is Dominic. Is it not yours? Next one. Yeah, Joe is.
Hi, I'm Dominic. I'm working on the rendering team, and today I want to talk about some highlights in the area of fonts. Which one's forward? Green. Sorry. Okay, two highlights in the area of fonts. First, I want to talk about native support for AAT fonts and font matching improvements. What are AAT fonts? AAT fonts are a type of system font that you find on Mac, and they work a bit different to OpenType fonts. So, as you may know, in fonts there's not only glyphs, but there's also logic in the fonts. So to sort of determine how to form a ligature and how to do other OpenType features. So in AAT, this logic is encoded as a state machine, whereas in OpenType, this logic is composed of lookup tables. So before, our architecture looked something like this. When Blink had to process a piece of text, we would have to ask Halfbus to shape it for us, and then Halfbus looks at the font and determines whether it's an AAT font or an OpenType font. And if it was an AAT font, it had to go through some complicated adapter code and do some massaging of the data structures to be able to run it through core text and then convert the results back so that Blink can use it in the Halfbus data structures. Now the architecture looks like this. And so we've taught Halfbus to be able to use these Mac system fonts directly. And it works quite well for benchmarks like HTML full render, which is going down from 4.3 seconds to about 3 seconds. Also, if we're measuring text shaping directly, we see speedups between 3 times and 12 times. So thank you to Bedat, who's the maintainer of Halfbus, and Ibrahim, he's working on the Halfbus project as well. Next, font matching improvements. There's two types of font matching in Blink. One is family matching, so when you resolve style against the available fonts. The second one is what I would call local matching, which means resolving the source line of a font face declaration. Google Fonts on Android uses source local as an optimization to access the fonts that are installed on Android directly. Without correct source local matching, those installed fonts cannot be correctly used. Before using source local matching, 12 fonts were accessible. Now 240 installed fonts are available. And what this looks like is seen here. On the left side, local is loading instantly. And for Roboto Condensed and Google Sans, these have to be loaded from the web. So native AAT support brings 3 to 12 times improvements. Source local brings better matching on Android.
Thank you very much. So the next speaker is Seth Hampson.
Hi, my name's Seth, and I'm going to tell you a little bit about the RTC Quick Transport Web API that we built. So a little bit about the motivation behind this. We wanted to build a low-level data transport that was high performance in the web, and we wanted to build it on top of Quick. We also wanted to build a modern API, like something that incorporates send-side back pressure, so if JavaScript freezes up, or say you can't process data fast enough, the send side will stop sending. And I guess part of the motivation that started this is for WebRTC like next version APIs, which includes lower level like components and no SDP. And if you're curious what that is, it's a big text blob that's used to negotiate pure connection parameters, and developers tend to hate it. Cool. So basically what it is, it exposes a quick connection and quick streams for reading and writing. We built it for the peer-to-peer case, so it's built on top of ICE, which is a networking protocol for establishing like a peer-to-peer connection. And it's standalone, so it doesn't include the entire RTC peer connection stack for like video and voice. And then because it's on the web and built on top of Quick, includes built-in encryption and congestion control. So I'm gonna do a little file transfer demo that we built to just point developers to, because we have an origin trial right now. Does it work? Yeah, so basically you can see some stats, transferring a file, and what I'm gonna do is like pause the receive side, and the back pressure is gonna stop the send side from sending. It's kind of at the bottom, so it's hard to see. And then I'm gonna like send 2 files, and is it gonna continue? And because it's built on Quick, there's no head of line blocking between streams, so you can see that they're both transferring at the same rate. All right. So you may be asking, like, what's next? Can we go next slide? Oh no. Oh, is there a? Okay, yeah. Okay, so you may be asking what's next. Like I said, we have an origin trial right now. It's in versions 73 through 75. And we really want to get developer feedback. Like, it's really important to us. So if you know anyone that wants to try it out, let them know. Get them involved. There's also a lot of discussion happening right now around like a client-server API that doesn't include ICE. So if you want to get involved in this discussion, we're hoping to move this into the Web Incubator community group. And there's like discussions going on about like a more generic data transport in the web. And that's pretty much it. So if you want to get involved, like, come talk to us. Thanks.
Thank you very much. So the next speaker is Mark.
Hello, hello. So, green. Okay, good. No, whoops. Okay, so I'm going to talk about Lucy, what Lucy gives you. But before, what is Lucy? Raise your hand if you know what it means. Ah, there's a few. So it's layered, universal, continuous integration. It's in opposition to monolithic software like Buildbot and Jenkins. It's actually a stack of software, but we also have a really cute mascot thanks to Tiffany Zhang.
It's called Lucy. I'm personally working on swarming, so you can see the inspiration there. So the nice thing I have to say, so you should be happy about it, it's that the dot is gone. So our system is now completely replaced. Hopefully you didn't notice, that was the goal. We invested a lot of work in that. So back on what is Lucy. It's actually microservices before it was cool, and it's also serverless before it was a name. It's basically, if you have one takeaway, it's that it scales. It happens that Blink has a lot of tests, and it happens that when you do changes in Blink, it actually runs them and also in Chromium, which has a lot of tests too, which actually happens that it's actually a lot of tests to run. So we run around 14 years worth of builds and tests, and that excludes Goma. Also, there's the binary size. They are huge. We actually build in debug, run test in debug too. So can anyone guess how much binaries we can generate in 1 year? Maybe, 10 terabytes, yeah. Maybe more, who knows? So around 9 petabytes. So, yeah. So guess why I know. So there's actually a lot of I/O too. So it happens that our worker has to send these binaries. And what's the secret? So basically, we have a reproducible environment, and we have a few key features. So we actually recycle our VMs. Everything is content address, so the inputs, but most importantly, the outputs. And the important point here is that we have really strong security and audit in the system, so really like that. We have actually, so just for your information, we actually have a fair number of internal customers. But the code itself is actually open source. So that's it. Thanks.
Thank you very much. So the final speaker is Daniel.
Hi, I'm Daniel. Just wanted to give a quick information dump about the Chromium Slack. This is actually different from the Blink-on Slack. It's a place for open discussion about Chromium development. And we want to have this because if all the discussion is on the internal chats, it's kind of hard to collaborate with Microsoft, Opera, or anyone else working on Chromium outside. So please do kind of join on if you want, or whatever. If you don't have a Chromium.org account, you need to email that alias though. Sorry, kind of sucks. These are just the restrictions. Also, there's custom emoji, and they're awesome. So, yay. Finally, there's a few, I think, rough edges still. Like, if you don't have a Chromium.org account, it's kind of hard to get an invite. You need to set up two-factor, et cetera, et cetera. So if you don't use it and you have like reasons that can be fixed, please do talk to us. Like, we'd love to know what they are to make it easier for everyone to join. Thanks.
So we are on time. So yay! So thank you very much for coming to the Lightning Talk. So 18 more Lightning Talks are going to be scheduled tomorrow. So see you tomorrow. Bye.
Thanks so much. That's a wrap for day one. The reception is right outside in the atrium, and I'll see you out there. And thank you very much.